Hello everyone. All right, this little video is going to be for statistics assignment number 8 here, analyzing residuals. Okay, so you already have the period 8 class notes, but if you missed class or don't quite understand what's going on, we are using the graphing calculator to construct residual plots, and then we're using those residual plots to determine whether the model is appropriate or not. All right, it's just a little review here. Little review. Okay, I mean, if you already went to class and you've already seen all this and all this has been demonstrated, this is for those who maybe missed class or want to see it again. Okay, so we got the scatter plot, right? And you got all these little dots. Each one of these dots is one little data point, and the scatter plot is representing the scatter of all the data points. Okay, when we throw this scatter plot into our calculators or machines to do the residual, we get this residual plot. All right. So maybe take a moment, pause the video, and determine what do you know about residual plots and how can you analyze this one right here. All right. Through the magic of video, you were able to pause me and now unpause me, and now I'm back. All right. If you need more time, you need to pause me. All right. Otherwise, I'm going to talk about this. So I'm looking at this residual plot and I'm noticing something. I'm noticing a pattern developing. All my points in the beginning are below the line, and then all my points and towards the middle are above the line. They kind of stay above the line until I get these points over here, which are below the line again. Okay, so this residual plot is telling me that my data is doing something a little bit different than my line. All right, my data is doing something a little bit different than my line. Let me just draw a line here. Let me use the line tool. I'm going to use the line tool. Oop. Let me try to create a linear line that goes through this data. Well, that was not quite what I wanted, but okay. All right, I'm struggling here. I'm struggling. I gotta be honest. Whoop. Oh, less than ideal. Less than ideal. Google Slides. Come on, undo the thing I did so that I can fix the thing I want to fix. All right, I'm gonna undo a few things. Go back to the line tool. Let me try this again. My mouse is being funny. It's being funny. All right, let me try one more time. This time I use my trackpad since it seems like my mouse is giving me difficulties today. All right, there it is. Much better. So I'm trying to draw a line that will go through my data. I'm trying to make it fit. I'm trying to make it fit all this the best I can. But that's a pretty decent. That's pretty decent all said and told. That line right there. All my dots are really close to that line, but you can kind of see the problem that's developing. I got dots in the beginning. I got I got dots in the beginning that are below the line, right? And then dots go above the line, and they come back down below the line. So I can when I draw the straight line on my scatter plot, I can see I'm having a problem here that this line, this red line here, is not a good fit for the curved nature of the data that I got going on. I might not see that at first when I look at the scatter plot, but the residual makes this apparent. So the pattern in the residual plot indicates that our model is not, put in big cases there, appropriate. Right? The pattern in our residual plot should indicate to us that the model is not appropriate. Let me change the color. There we go. Maybe orange. I don't know. Not something I don't like orange. Maybe dark blue or something. Just to make that pop a bit. All right. The pattern in our residual plot indicates that the model does not fit the shape of the data. The data is kind of doing a pattern thing around our model, indicating to us that the model may not be the right shape for the data. All right. Here's our second scatter plot. All right. You look at that. And then they do the residual. And notice what we have for the residual. Again, we have another pattern developing. This time, right, if I was to draw a line in here somewhere, it'd be something like, oh, I gotta stop. I gotta learn not to use this mouse. What is wrong with this mouse? I'm gonna blame it on the mouse, people. That's my official story, and I'm sticking with it. I'm gonna use trackpad this time. I'm gonna try. But even, I'm trying to do my best on a line that fits that data, but, sorry. No matter what I do, even if I try to bring that down a bit to fit more, and then I lose some of the other dots. See how that, no matter what, I'm going to get a compromise there. So this residual shows me that in the beginning, I'm going to have dots above my line, and then I'm going to have a whole bunch of dots below my line, and then I'm going to have a dots above my line again, right? Which shows me a pattern, which again, the pattern in the residual plot indicates that the model, that the linear model we're using is not, in big uppercase, appropriate. That's what we need to understand. That the pattern in this case, patterns in residual plots, give us an indication that our model is not the best, it's not the most appropriate choice. That's key. That's clutch. That's what we need to understand here. All right. So what does it mean when the points in the residual plot appear to be random with no visible pattern? Like this residual plot, right? There's no pattern on this one. Well, okay, I'm not going to use the mouse this time, so I can't blame it on the mouse. Let me try to draw a line with my trackpad, which for some reason is more accurate today than my mouse, right? I'm going to get a linear model, and now the shape of the residual matches, right? Just a scattering of the data, which indicates to me that this linear model is running the same shape as my data, right? That my model is the same shape as my data, as the direction my data is going in, which tells me that this time a scattered residual, that tells me the model is appropriate. The scattered residual plot indicates that the model is appropriate. I'm the typing on my mouse, can I? Well, that's not going to work. All right, making that blue. All right, that's that page. I'm moving on. If you need to still see this, then you're just going to have to pause me. All right, here's a scatter plot, right? We would be tempted to say, if we were just looking at this right here, right, what would you say? Would you say that that's linear, exponential, quadratic? What do you think? Well, in our 8th period class, everybody said linear. And yeah, even me, I would look at this and be like, that looks pretty darn linear to me. I tried to use the mouse. Look at that. Try to use the mouse. What have I learned? I have not learned to stop using the mouse for this particular task. Okay, trackpad this time. I'm going to try to draw a linear line. Now let me see if I draw a line, what happens. Ah, when I draw the line in, we can begin to see that it might not be the best. Linear might not be the best choice. But we didn't see that until the straight line got drawn in. So let's look at the residual. Here's the residual plot. When we might have been tempted to say this was a linear function would be the best model for this, but when we do up the residual plot, we see the shape appearing, the pattern appearing. And this pattern indicates to us that the shape of the data is not suggestive of a straight line. It's suggestive of some kind of curved line, probably an exponential or a quadratic. Right? So that's why we're showing you these residuals, because the residuals show you something that you don't always see just by looking at the scatter plot. Now, when it's obvious, you can just look at the scatter plot and you can see a shape, then that's great. It's wonderful. But sometimes it's not obvious. You need a residual plot to really know what's going on. So the question is, how did this residual plot result from the original scatter plot? The residuals are calculated from the observed data minus the predicted data, and the pattern indicates that the model is not in capital letters, appropriate. Okay, let me zoom back out. All right, the residuals are calculated from the observed data minus the predicted data. That's how I got this. So like these two dots above this line, it's kind of like, what is a good example of this? Let me kind of give you a demonstration here. I'm going to take a little snippet. I copy that. I'm going to paste it. Let me show you what's going on with this residual plot. Yep. No. Well, apparently it didn't like me. Okay. There we go. right? I take the scatter plot, and if I was to twist the scatter plot and make the line of best fit to be horizontal, if I was to take this line here, if I was turn it to be horizontal, and I change the scale to really be able to see what's going on, right? And if I was to zoom in, no, I didn't want to do that. Let's just zoom in here. I can see that, I start with maybe some points that are above the line, and then over time, so probably my line is too tall. I probably need to move my line down a little bit. I'm going to try to do it with my mouse, right? And then, of course, I would need a new picture. But you see in the scatter plot, I've got a couple dots that are above my line, and then I have some dots that come below my line. Again, it's so tiny here. It looks straight, but the residual plot really makes it pop, makes you be able to see it. And then we have a dot above the line over here. That's this dot over here. So there's a connection between the scatter plot and the residual. The residual is kind of like it's going to share the same pattern as the scatter plot, but maybe zoomed in. Okay. All right, for this one, so let's do a little calculator hygiene. Remember how to do that? Maybe you want to pause the video and just practice doing your calculator hygiene. If you're not, but if you already know how to do it, just let me show you how, okay? It's second plus 7, 1, 2. That clears your calculator. Again, so it's a little slower. Second, blue second button, the plus button. See mem is that stands for memory. Mem in blue. All right, that's the memory menu. And then 7, reset. 1, RAM. 2, reset. And it all gets reset. And now that everything's reset, I am going to start, I'm going to turn on stat plot. Second, and see stat plots in blue here, y equals. Second, y equals, gets me into the stat plot menu, and it's just enter, enter from here. Enter, enter. And now my stat plot is on. All right, this is good. This is good. Second mode is, see how it says quit there? Often can get you out of menus if you don't want to be in them. So that's a way of navigating away from a menu you don't want to be in anymore. Okay, I'm going to enter this data. I'm going to enter this data into my calculator. And you guys are working on a Chromebook, so often that you might have to use the little zoom magnifying glass to zoom in on this to be able to see it. To enter data in my calculator, press stat and enter. Again, I'll show that again. Stat and enter, and I can start entering this data. I would encourage you to use the keys on your keyboard. That might be a little bit more comfortable for you to enter this data than clicking on the physical calculator. I'm doing this kind of fast, so I just want to show you the general principles of what we're doing here. You can follow along or not. I would encourage you to follow along if you can. You can always pause me if I'm going too fast. And the reason why I encourage you to follow along and just do this on your calculator, as much as that seems like extra work, who wants that? Who wants extra work? Well, the thing is actually doing it will, looking at it, you'll learn. You'll learn by just watching. You will learn just by watching me. But you'll learn even more. You'll learn even more if you're actually doing it as well, because then you're you're seeing and hearing, but then you're also doing. It gets the doing memory, the procedural memory gets stored in different places, so you'll have a better, stronger memory of the event and what you learned, and that will give you a better, stronger learning experience. The data shows. Science, people, trust the science. Do the extra work. It will pay off because you'll get a better learning experience out of it. And then you'll feel less confused, and then it'll make you happier, and it'll make life easier in terms of statistics. And, who wants to be stressed out? A little bit of practice makes life just a little bit more enjoyable. Okay, I've got my data in, and now I want to construct a scatter plot of the data set. Remember how to do that? Zoom stat will give me a nice window to construct this scatter plot. Zoom, and down here is zoom stat. It's actually number 9, so you can just press 9 if you want, or enter. And so I should have a scatter plot that looks like this. Use the little squiggle. Use the scribble tool. See on the line tool, scribble. Use that to do these graphs. So for instance, I got 20, 100.125. So 20, 100.125, right about right there. All right. This is where I wish I could just fast forward, but I'm not going to go and play with that kind of video editing stuff. So, oh, that's not what I wanted. I didn't want that. So I'm just going to kind of flub it at this point because I know what the general shape should be. So I know that I should have something that looks like a straight line. And if I was really needed to be, if it said graph, if it said graph, it says construct. Okay, because it says construct, I will let you know. Construct means we actually got to do it the right way. I'm not going to go do it the right way. I'm just going to eyeball it. And I'm going to hope for the best. If it said sketch, we get to have a lot more latitude. We just need the general right shape. But it says construct. Construct is a little more technical. Let's see if I'm anywhere near what I should be. At 30, I should be at 100.374. At 30, I'm at 100. Oh, I'm not too bad off. I'm not too bad off. All right. That would be. I wouldn't get too many points taken off from this. Okay. If this was Regents. Okay. From here, it says write an equation to model this relationship. All right. Maybe you want to think how you'd use your calculator to create or build an equation. Pause me if you need more thinking time. All right. Because I'm just going to show it. I'm going to go stat. I'm going to go to the calc menu. Press the right arrow key to get over the calc menu, and I want this linear regression will give me a linear equation. Enter like 5 times, 6 times, and here I have the makings of the linear equation. It seems different from what I have calculated previously. Did I get all the data in there correctly? It makes me want to just check. Let me just check. I probably shouldn't check since unfortunately it doesn't. I'm not going to be able to check because it rounds things. So, oh, I can look at the bottom though. I could do that. I'm just doing a quick check to see if my data matches. I just don't remember. Everything's looking good. Yeah, everything looks good. So I'm going to go stat, calc, linreg, enter, 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 enter. I'm going to write this equation. Sorry for coughing at you. Y equals, all right, A times X plus B. That's the format the calculator is telling me that this equation takes, but then it tells me what A is. A is 0.0, went around to the nearest hundredths, 2, and then plus B, it tells me what B is. B is going to be 99.662. All right, there is an equation I can use to model this line. If you need this slide more, you'll just pause it. I'm going to the next slide. All right, let me zoom out a bit so I can see what's going on. Okay, I got this data. Let's go calculate these residuals. Remember how to do that? I'm going to give you a second to think how you can go ahead and do that. To calculate these residuals for this data. All right, pause if you need more time. I'm just going to show you how to do this. So if I remember, I pressed graph, zoom stat to get to the scatter plot, but I want a residual plot now. I'm going to use technology. That's that first learning target. Using technology to construct a residual plot. Here goes. Second, stat plot. Right. I'm going to go back into the stat plot menu. Press enter. This time I want to change the Y list. I want to change this Y list to what? I want to change it to resid. All right. So to do that, I got to press second. Do you see how list is in blue here? So if I press the second stat button, it'll get me into the list menu. And I should see resid as my 7th option. If you don't see resid on your calculator, it's because you haven't done the regression yet. You didn't follow all these steps. Once you do a regression, then the calculator stores all of the residuals for that regression. All right, but without that, if you don't do a regression, then and those residuals aren't stored, it won't even give you this option. All right, enter, and then enter one more time. Okay, so my Y list is resid. Let me get the residuals, calculate them, okay? I'm going to press stat once more. I'm going to press enter. I would like you to put the residuals in list 3. Do you remember how to do that from the last lesson? Pause the video and see if you can remember how to make the residuals happen into list 3 here. Through video magic, you paused me, you unpaused me, you gave this a try. I'm glad you gave it a try. That actually helps you learn better when you would make an attempt. All right? I went over here and I highlighted list 3. I press second stat again to get into a list menu. I can change that to resid again. Press enter, and it calculates all the residuals for me. So I have, let's see, 0.00605, .00113, and I'm total. I didn't click. I need to click the next residual instead of just typing enter. I'm used to use the spreadsheets here. 00113, and I'm totally not obeying the rules of significant. I did the enter thing again. Old habits are hard to break. I'm totally not obeying the rules of significant figures here. I am taking right. I have up to 3 places of accuracy here, and I'm taking this out way past that, just because I'm just wanting to demonstrate demonstrate how to calculate the residuals here. Oh, I need a negative in front of here, don't I? Negative 0.0027, and I need to click. Again, my temptation is to pretend that this is a spreadsheet because it feels like a spreadsheet. 0036. 0. No, I need a negative. Negative 0.0045. All right, negative 0.0025. And now I have to go down. And 27. Oh, look at that. I got something really interesting going on there. For 28, 27 is negative 0.0034. 28 is 7e minus 4. What's that? That is 0.4 zeros, right? 1, 2, 3, 4, and a 7. And I need to make sure I get to go over 7 places. So I'm changing the decimal to 1, 2, 3, 4. No, I need that decimal here. I need the decimal there, not there. Oh, stop doing that. Oh, okay, it did it because I'm too small of a number. There, now it'll, okay. All right, this 7e to the 4 is scientific notation for 10 to the negative 4th power, which is telling me that I got a number that's really, really close to 0. It's really, really close to 0. It's so close to 0 that it's not even going to display all the zeros in front of it. In fact, we could just round that to say 0. I think in class we did round these. In fact, now that I think about it, probably to the thousands place, probably. That'd be the smart move. I didn't do that this time. Forgot. That would be the proper way to do it. We want to be aware of those significant digits when we're doing science. Okay? When we're doing math, we can do calculations beyond the accuracy of our measurements because everything's abstract numbers. But in science, you can't go beyond the accuracy of your measurements. All right, anyway. So now we're going to do the scatter plot, or the residual plot, all right? Residual plot, all right? So how do I do a residual plot? Remember that second, y equals. I need to go in here, and this needs to be resid, okay? Once you do that, zoom stat should take us there. Zoom. What have I done? What have I done? I need to quit. Zoom. Go down to stat. Stat. Right there. Enter. Aha, beautiful. Now I can just start moving, my dots where I think they would be to kind of sketch out a residual plot. If you need more time to do this, you just pause me and make me be quiet. Remember, the beautiful thing about these videos is you can make me talk faster if you really need me to. All right, you can make me talk slower, which I am not able to do in real life. Ever try to talk really, really slow? It's not easy to keep it up. And last one, somewhere there. So I'm just copying the residual plot I kind of see here. Do I see a clear curve in the residual plot? Yes. There is a pattern in the residual plot indicating that our model is not, in capital letters, appropriate. All right, that's what the residual plot tells us. That is how to get it done. Okay, we did more, right? On Friday, we put this data in our calculator. We ran a scatter plot of this. We found out that all the residuals ended up being 0. We ran the equation. You can, all your residuals here should all be on this line because if all your residuals are 0, then that means that none of them differed, right? If all your residuals are 0, that means your data is all perfectly on your model, and there's no the residuals are all 0, which means all the data is perfectly on your model. Your model is a perfect fit for your data. All right, and if you try to do this on the scatter plot, it'll say error window something. That's because its calculator has a hard time figuring out what the window would be when everything's perfect. And then you're going to answer 12 and 13 on your own, and then turn this in. All right, that's this assignment number 8. Okay, I hope you guys have a great weekend. This is Mr. Solt signing off. I'll see you in class.